Good day, everybody. Welcome to my channel and thank you for joining. Today we are going to complete our topic of standard notation or standard form. Remember, scientific notation is exactly the same as standard form. And remember, the form of a standard form, the way that it looks like, is a number multiplied by 10 to the power of another number. That is what standard form is. And remember, a is always smaller than 10. So this a is always smaller than 10. Now, the way that we're going to handle this off or end off this chapter is we are going to do some equations. Now, if you are new to my channel, please welcome. And if you have watched my previous videos, you'll know that we normally do about 6 equations together. We start from very easy to very difficult, and number 5 and number 6 tends to be our longer kind of questions. So that's why we have a part 2 when we are doing our calculations. Okay, if I were you, I would have my pen and my book available. Always, if you want to use a pen, you can, but if you, I prefer a pencil, because a pencil you can actually erase when you make a mistake, so you don't have a lot of scribblings, because math you tend to make quite a few mistakes if you're not in the habit of practicing. Okay, so let's start with our first equation. We have a number that we need to change into standard form. Now, the way that we do it, as per usual, we start at the decimal point and we count our numbers up. So let me just get another color pen here and then we can start with that. Okay, so we counting 1, 2, 3, 4. Remember, it must be smaller than 10, but it should be bigger than 1. So we stop at 6. So our answer would be 6.4 times 10 to the power of 1, 2, 3, 4 jumps. -4. -4, why? Because we're moving to the right. We're getting smaller, so it should be a negative number. Okay, now we're going into our equations where we actually use standard form in our equations. Remember, this is revision from grade 8 work, from level 8 work. So if you haven't done this yet, just follow with the example, and if you're still struggling, drop me a comment and I will post more videos to help you understand how to do these equations. Okay, so let's look at how we should solve this. There are actually 2 ways to solve this equation. One is you can change the numbers into normal writing or into standard notation. So that when you have this is a negative number, so we're changing it to a 0 point. How many times do we jump? 3, and then we get to 7. So 1, 2, 7. So there's 3 jumps. 1, 2, 3. Then we have multiplied by, this is also a negative number, so we start with a 0. How many times do we jump? 5 times. So let's see. 1, 2, 3, 4, and 6. So there's 5 jumps. 1, 2, 3, 4, 5 jumps. Okay, now we can multiply this equation. So we say 7 times 6 would be 42. Okay, because both of these numbers are at the end of their number that they have given us here, we write the 42 also at the end of the number. So we know there will be a buttload of zeros in front of this number to start with. So let's see how many numbers we're going to look at. The way that we know how many numbers we're actually going to, how many zeros we're going to have in front of this number is we're going to count how many zeros are after the decimal point. So this one we have 1, 2, so we have 1, 2, 3, 4, 5, 6. Okay, so we have 6 numbers. So then we're going to have 6 zeros in front of this number. So we have 1, 2, 3, 4, 5, 6, and then we have decimal point and a 0. And that would be our answer. Now, if we need to write this back into standard form or scientific notation, we're going to count how many jumps. We have 1, 2, 3, 4, 5, 6, 7. So our answer would be 4.2 times 10 to the power of negative 7. That is one way of working it out. And for simple equations, it is really easy to work it out this way. But there is another way, and I need to show you that way as well, using indices. You know, the thing that we learned before? So just go back to my indice videos, go check how to do that, and remember to memorize your rules. Okay, so first of all, we need to break down this equation so we work with different kinds of numbers. So we take the whole numbers, which is 6 and 7. We pop that into one equation. So 7 times 6, y times, because there's a times in between the brackets. Then we do the same with the 10. So 10 to the power of negative 3 times 10 to the power of negative 5. And those who know their indice rules, you can already see what we can do here. But before we get to that point, let's solve this equation. So 7 times 6 would be 42. Now we can solve this. We need to follow which rule of indices? The multiplication rule. So it says that if you have the same basis but different powers, you need to add the powers. Okay, so let's do that. So we have 10 negative 3 plus negative 5. Okay, so then negative 3 plus negative 5, we need to add these two numbers together but still keep the original value, okay, or the original identity of the number. So then we have 10 to the power of negative 8. But hold on, we can't just combine these now. This is a 42. Our scientific notation needs to be smaller than 10, which means this one will become 4.2. 4.2 times 10 to the power of 1. And what is 1 minus 8? That would be negative 7. So we have 4.2 times 10 to the power of negative 7. We subtract, we do this two together. Okay, so 1 minus 8 gives you negative 7. So that is where our answer comes from. And you can see that this answer matches this answer, and we are well on our way. Okay, for our next equation, let's see if we can finish these 4 equations. With this one, they want us to find if it's true. So if it is true. Okay. So let's see, how do we work that out? First of all, we need to actually do the calculations to see, will we get to the same answer? Okay, so we can see that this is an addition equation, which means our powers will stay exactly the same. There will be no changes in the power. The only thing that might change is our whole number. And 3 plus 4 gives us 7. So 3 plus 4 gives us 7. Okay, and which means, and then these symbols, they will stay the same because this is an addition equation, not a multiplication equation, which means yes, it would be 7 times 10 to the power of negative 5. Now if you do the equation like this, your teacher will see that yes, you agree, or you have proven that this equation is true, that 3 times 10 to the power of negative 5 plus 4 times 10 to the power of negative 5 equals to 7 times 10 to the power of negative 5. And that is how you prove it, by actually calculating it and working it out. So this looks difficult, but it's not really difficult. So yes, this is true. Okay, let's look at our next one. So they're asking us which one is smaller. So which is smaller? Okay. So would this one be smaller, or would that one be smaller? Remember, the larger the decimal number here, the more zeros there are before we get to the decimal point. To give you an example, let's write it out as normal numbers. So we have 0.0000. Remember 4 jumps because there's negative 5, 4 jumps, and then 6, 7, and then we have 0 point, and we have 6 jumps there. So we have 5 jumps, and then we get to 8. 1, 2, 3, 4, 5, and then 8. Now, which one is smaller? So automatically the one that has the most zeros, that one would be smaller. So the smaller one would be 8.0 times 10 to the power of negative 6. So you can look at the power digit, and then that digit will tell you exactly which one would be smaller. It doesn't matter what this number is here, because that one is misleading, but the number that is more important is the power number to actually understand which one would be bigger or smaller. So I hope you understand how we calculated these equations. Let me know if I need to put a new video on with a similar equations, or if I need to spend more time on a specific equation. Thank you so much, and I'll see you on part 2.